Hello students, welcome. Previously, lesson 4, form 4 topic 3, we were dealing with factors affecting the rate of a reaction. Today, lesson 5, we are going to start with reversible reactions and we are going to do equilibrium. So we are saying reversible reactions can take place in both forward and backward or reverse directions. In this case, none of the reactants is completely used up and the reaction does not go on completion. When paper burns, the ash produced cannot be changed back to the original paper. That means a permanent reaction has taken place. And we said the reaction is said to be irreversible. Then we are told when ice is heated, it melts to become liquid water. On further heating, the liquid water changes to steam. If this steam is cooled, it changes back to liquid water. On further cooling, ice is formed again. And we are saying this reaction is said to be reversible. Okay, we move. We have examples of reversible reactions. Here we have ice. When it is heated, it becomes liquid water. When that liquid water is heated, it becomes steam. So if we take this steam and we cool, we are going to form liquid water. On further cooling, we are going to form ice. Other examples of reversible reactions include ammonium chloride being heated to form ammonia gas and also hydrogen chloride gas. On cooling, ammonia gas combines with hydrogen chloride gas to form ammonium chloride. So here we have iodine. When heated, we are going to form iodine vapor. On cooling, that iodine vapor turns back to original iodine. Then example 3, we are having that hydrated cobalt 2 sulfate. When it is heated, we are going to get anhydrous cobalt 2 sulfate and also we are going to get water. So remember, hydrated cobalt 2 sulfate is blue. So when we heat, we are going to form white anhydrous cobalt 2 sulfate. Here number 4, we are having cobalt 2 chloride. Cobalt 2 chloride, anhydrous cobalt 2, hydrated cobalt 2 chloride is first of all pink. So when we heat, we are going to get cobalt 2 chloride and also water. So anhydrous cobalt 2 chloride will be blue. Okay, we are going to go next to the other part. That's equilibrium. So what is dynamic equilibrium? It is a state of balance in which both forward and backward reactions are taking place at the same rate, but of different directions. So we're having characteristics of dynamic equilibriums. 1, it occurs in a closed system, so as none of the reactants and products escapes into the atmosphere. Number 2, rate of forward reaction is the same as backward reaction, or the rate of backward reaction. So number 3, there is no observable changes. Okay, next we are having equilibrium can be illustrated graphically as shown below. So these are the two graphs we have. Okay, the first one, we are having rate here, and we are having point N and also M. So this is reverse reaction, and this one is the forward reaction. So this is point N, where forward reaction and also backward reactions or reverse reaction at equal rates. So we're saying here, point M represents the time taken for the equilibrium to be established. This point M, because here we're going to have time. This is where we have time. So while point N shows rate of forward reaction is equal to the rate of reverse or backward reaction, or rate of reaction is constant. So this other graph, we have amount and also time. Then we have product, and here we have reactants. Okay, we are having here equilibrium. That means no change in amounts. So we are saying flattening of the curves shows that equilibrium has been attained. So the amount of reactant decreases as that of the products increases. Okay, we move. So next we are going to go to factors affecting equilibrium. So we are told once equilibrium has been attained, the position of the equilibrium can be affected by different physical or several physical factors, such as 1, concentration, Romeo 2, pressure, Romeo 3, temperature, Romeo 4, we have catalyst. So we are saying the effect of these factors are subjected to the Lachitelius principle. The Lachitelius principle, which states that when a change in condition is applied to a system in equilibrium, the system moves so as to oppose the change. So during the exam, you can be told state the Lachitelius principle. So we go to the first fact, that Romeo 1, effect of concentration on the position of equilibrium. We are saying when the concentration of one of the reagents is increased, the equilibrium shifts the direction that reduces its concentration. And if the concentration of one reagent is decreased, the equilibrium shifts the direction that increases its concentration. You have to note that also. So we go to examples. Number 1, we are told a dynamic equilibrium between dichromate and chromate ions is established as shown in the question below. So we have the question like that. Here we have the dichromate, and here we have the chromate ions. Okay, so part A of the question, we are told state and explain the observation that will be made if a few pellets of potassium hydroxide are added to the equilibrium mixture. So we are given here a condition of adding potassium hydroxide to the equilibrium. So what is potassium hydroxide, or what does potassium hydroxide has? It has hydroxide ions, and this equilibrium mixture, we have hydroxide ions on the reactant side or on the left hand side of the question. So that means if we increase the concentration of the hydroxide ions, that means the equilibrium shifts to the right to reduce the concentration of the hydroxide ions, which is induced or introduced into the system. So the observation will be the yellow color of the solution intensify, or you will see that the orange color of the solution fades, because more of the hydroxide ions will be reacting with dichromate, thereby reducing its color. So those are the two sides that we can talk about. So we can say the first one, or on our side, we can just say the color of the solution. The color of the solution becomes yellow. Or we can say the color of the mixture becomes yellow. Let me just take that. The color of the mixture becomes yellow. What is the reason? This is because the equilibrium shifts to the right since more hydroxide ions have been added, hence reducing the concentration of the dichromate. The concentration of the dichromate. So therefore, the equilibrium will shift to the right, or that means forward reaction is favored, because we are supposed to relieve the stress that we have applied on the equilibrium. So part B of the question, we are told state and explain the observation that will be made if a few drops of concentrated sulfuric acid are added to the equilibrium mixture. And this was the equilibrium question, or the question that we are given. So what will be the effect of adding concentrated sulfuric acid, or few drops of concentrated sulfuric acid? Remember, you are given concentrated sulfuric acid, not dilute sulfuric acid. That means concentrated sulfuric acid is a drying agent, so it removes or it absorbs water from the equilibrium. It absorbs or removes water from the system. So that means the equilibrium has to favor the side that water has been removed. So that means forward reaction will be favored. That means yellow color of the mixture will be the one that been intensified. So we are going to say yellow color of the mixture is intensified. So what will be the reason? The reason will be this is because concentrated sulfuric 6 acid is a drying agent, hence absorbs or removes water from the system. So this causes the equilibrium to shift to the right to form more water. That will be our answer. So, but see, we are told state and explain the observation that will be observed, that will be made if dilute hydrochloric acid is added to the equilibrium mixture. This is the question that we had. So we are having dilute hydrochloric acid. So which part of the question will have an effect on adding dilute hydrochloric acid? So here we have hydroxide ions. So that means hydrochloric acid has hydrogen ions which will react with the hydroxide ions, thereby reducing the concentration of the hydroxide ion from the system. So that means the system will favor the side that its concentration is reduced. That means the left-hand side of the equation. So we will see that the equilibrium shifting to the left, or backward reaction being favored. So that means the orange color of the mixture is the one that will be intensified. So we are going to say orange color. Of the mixture intensified or intensify. So reason, this is because dilute hydrochloric acid reduces the concentration of hydroxide ions. The concentration of hydroxide ions from the system. Hence, we can see backward reaction. Backward reaction being favored. Backward reaction is favored so as to increase the concentration of hydroxide ions. That will be our answer. So we go to question 2. We are told consider the equilibrium below. So we have 2 mole of sulfur peroxide gas plus 1 mole of oxygen gas, giving us 2 moles of sulfur 6 oxide gas. So we are told explain the effect on yield or on the yield of sulfur 6 oxide if, from 1, more oxygen is bombed into the system. So if more oxygen is bombed into the system, that means oxygen is in the left side of the equation. If we increase the concentration of oxygen gas, that means we have the equilibrium will shift to the right so as to remove the stress or to reduce the concentration of the oxygen gas. So that means the yield of sulfur 6 oxide will be more or will increase. So I'm going to say the yield of sulfur 6 oxide will increase or increases. Reason being, this is because the equilibrium shifts to the right so as to reduce the concentration of oxygen. That will be the reason. So, but B, we are told there is removal of sulfur 4 oxide from the system. So, if there is a removal of sulfur 4 oxide from the system, that means the equilibrium will shift to the left so as to increase the concentration of the sulfur 4 oxide gas. That means the yield of sulfur 6 will be less or decrease. So we are going to say the yield of sulfur 6 oxide decreases. Reason, this is because the equilibrium shifts to the left so as to form more sulfur 4 oxide. Full stop. That will be the answer for that. So instead, if you don't want to say like that, you can say the yield of sulfur 6 oxide increases. Why? This is because the equilibrium shifts to the right, hence forward direction is favored. Then you stop your answer there. And this one, you say the yield of sulfur 6 oxide decreases. Reason, this is because the equilibrium shifts to the left, hence backward direction is favored. Then that will be your correct answer if you want to short it. Then next, we are going to go to the extended question as our number 3. Try to answer on your own. That's the end of our lesson.